Well, this lens cleaning, a lot of people have a lot of very strange ideas about what constitutes lens cleaning. The fact of the matter is most of these lenses are coated, and you really can't afford to put any chemicals on it. I mean, not window cleaner, nothing. The best and only thing you should use is water. And nice t-shirt, corner wet with nice soft material, corner wet with water. When you're cleaning them, don't push hard, but what you've got to do is you never go around like this. You always just go from one side to the other across the edge. Then right at the finish you just wipe the residue off the sides like that. Then it doesn't matter if you leave water on the lens, then you get the nice clean part of your t-shirt, and then just do this and just mop up the last of the water until all the moisture's gone like that. And what that does, you'll find you've left your anti-reflective coating on it, but you've also got probably the cleanest lens you've ever seen as well, because it won't attract any static because it's been moist. Just do the front of this and then put it back on the machine. T-shirt material is really good for this because it's nice and soft. You know that you won't scratch it if you don't push. And what you can do is you can also see if there's any dirt stuck in the inside of the lens this way. God only knows what you'd do if you ever had to pull one apart. It's not a pretty sight. This is the thing that you need to unscrew these lenses. If it's not magnetic, take it back or get it made magnetic, because it's almost an impossible task doing a lot of this stuff on your own without a long magnetic screwdriver that's really strong. Bung it back in the last one. Screw that back on there. The screws that are on the C element, these ones here, actually what I'll do, I'll just take this off because I want to show you something. For people that haven't done much fiddling with these tubes, never, ever, ever undo those screws. The Sony system for holding these C elements on is pretty simple, and it's basically an O-ring seal. And I've lost count of the number of times that people say, oh, I'll take the lenses off. So instead of just undoing those 4 lens screws, they undo these as well, because these are actually used as locators for the lenses. You undo those, basically what you're doing is unclamping the C element from in front of the tube, and the minute you undo that, if you knock the projector like that, the C element will fall out in your hand, and all of the impregnate will just go and then spew all over the inside of the machine. You can actually remove these, and I have done it. I've replaced it on tubes, I've replaced glycol in tubes, I've actually pulled entire tanks off these things. But whatever you do, make sure you've got yourself in a situation where the tube's standing on the neck with the face upwards if you ever attempted to take these C elements off. The other issue as well is that never ever leave one of these projectors anywhere near any sunlight. These are really nice magnifying glasses, and if the sun comes across the front of these lenses, they'll actually refract the sunlight round and focuses it very nicely on the tube face, and the C element that's in there is quite close to the tube face. And as the sun goes across the window that you've got it out the front of, you'll actually burn a really nice track right through these C elements because they're only made out of plastic. I've actually had a few machines that I've bought cheap where these C elements have been totally trashed, and it's not for the faint-hearted. You can change them. Last time I looked, they were about 135 US a C element, but it's a big job. You burn all 3, you're up for at least $400 in parts only. So keep them out of the sun or put lens covers on. Put this lens back on. If you ever need to pull these lenses off, don't even attempt to try and run the projector without having the earthing leads connected to the lens, because it'll just throw an error and won't start up. So I'll show you where I'll screw this back on. It's really quite strange, because the minute you try to start the projector, it starts up for about half a second, and then it just pulses. The fans will pulse, it'll go whoosh, you'll hear the fans start up, and then the machine will just close down. You know, I've heard a heap of people said, oh, I've taken the lenses off and cleaned them. What they forgot to do was put the earth leads back on. There's a reasonably complex protection circuit down on this PA board that'll actually crowbar the power supply down. Here we go, there's our red earth lead. There's the grey one. Terrific. Jam down the back. Come here. Retrieve the green one. Put that back on. And the blue one's right next door, that can go underneath. Push the power supply back in. In my experience, less than 10% of faults that you might think are the power supply in these things are actually the power supply. These have got a very complex protection circuit inside. Most of it's administered on this board here, the PA board. But even though the power supply might close down, doesn't necessarily mean it's the power supply that's the problem. In fact, 90% of the time it isn't. Very rarely, if ever, is this PA board faulty. So what it's doing, it's basically sensing from all over the machine, and all of those leads that are sensing from different areas that they thought were critical in protection all terminate on this board. And there's a diode matrix inside here that basically works as an OR gate and closes the power supply down if it fails. Now we've given this one a good clean. With a bit of luck, it'll fire up. Look, the 1292 is no different than any other CRT projector. Bad choices and bad alignment of the physical position of the projector in relationship to the screen mean that realistically you're going to use an awful lot of correction later on in terms of convergence and geometry to try and get the picture correct. So and if you do that, it's primarily only going to be correcting errors that you've made in the mechanical setup. Now, with the 1292, it's reasonably interesting, because if you think back when these machines were made, they're a 4x3 projector, and having programs like PJ Calc can only give you a rough guide. And I think the majority of people that have been setting these up for a reasonable period have come to the conclusion that the only real way of figuring out the alignment of these machines is to physically move them. Now, what we're going to do in a series of steps is we're going to do two things. We're going to physically make sure that the projector's in the right position in the centre of the screen and level. And we're also going to look at the inclination of the projector. Now, this particular one's on a table, which is probably not too bad in terms of what we're going to do, but for roof-mounted versions of these, roof-mounted installations, there's a couple of things you've got to keep in mind. The majority of houses have 8'6". Is that annoying? Probably. The majority of rooms have got 8'6" to 9' ceilings. Now, that can be a bit of an issue, because if you think back when these projectors were new, 4x3 picture, if you look in PJ Calc, the actual bottom of the projector casing here is level with the bottom of the 4x3 frame. So if you projected that parallel to the screen, that's where the bottom of a 4x3 picture is going to actually be thrown on the screen with the raster centralised in the tube face. But of course we're not using 4:3 these days, we're using 16:9. So the consequence of that is that even though we might have this mechanically set up, you'll find that the bottom of a 16:9 frame will be significantly higher up the wall for a table mounted projector than what it will be for 4:3. This can work in your advantage when it's on a table, because what it means is you actually translate the picture higher up the wall. And for a normal flat room seating position like this, having the projected image higher up the wall actually enables people that are sitting behind a row in front to actually see more of the picture, because you're not getting them cut off or interfering with people's heads. But for a roof mount, we've got a big problem, because now instead of the picture being higher and making life easier for us by projecting the picture further up towards the roof, we've now got the opposite situation where we've got the base of the projector parallel to the roof. For 4:3 the picture is pretty much directly to the top of the screen, but for 16:9 it's significantly lower, and we're talking a foot, 2 foot lower. Problem with that being, of course, that when you've got a second row trying to see over the heads of somebody in front, now the picture's translated further down to wall in 16:9, which means you can have head interference problems. Now, this is fixable, of course, but you obviously have to incline the projector away from its ideal. So what you find in most roof installations is that the front of the projector is actually inclined directly towards the roof and the back's dropped. This can be somewhere usually in the region of 3 to 5 degrees, and generally you actually incline the projector so that the top of the picture now on the roof mount is actually very close to the cornice or where the roof and the wall meet. So we've got two distinct series of problems. We've got an advantage for table mount for its physical positioning, but we've now got an issue where we have to incline the back of the projector away from the roof, which has implications for lens flapping, which are these rings here, and we'll get to those a little bit later on. First thing, of course, the projector has to be square to the centre of the screen. So if we measure across a typical screen, I don't know if you can follow easily, Matthew. I'll have a look at the width of this one. I might get you to grab the end of that. Okay, that's off and running. Thank you, able helper. So, we'll talk metric, because here in Australia we're metric. You'll have to translate into feet in the States.
I think it's got feet and inches on the tape.
And don't make it too easy for them. Right, now this particular screen, the actual image width is 2.604. 2.64 metres wide.
2.64 metres.
Yep.
Right, we're going to write that down.
You make a few notes.
Right, 2.64.
Okay, so look what I've done on my screen. I've actually got a marker, and I've put a very, very small dot right in the middle.
You'll actually find, Graham, that I think I've done the same
You've already
thing on
done
this.
it. Boy, geez, you're an ideas man.
I think.
Let's have a look.
There's a little
13. What is it? I think there is a little spot there.
Yes, there's a little mark.
Okay, so we know where the centre is. It's right there. Now the issue that we've got, of course, is that we can't measure this out and then project directly straight out to the projector. So we get stuck into the situation where we're basically only going to measure from diagonal corners. For a table mounted projector, the first thing I'd be doing is looking at the bottom of the projector housing there and projecting that forward so that it's actually level with the bottom of the screen, or with the bottom of a 4:3 screen, but of course it won't be in the right spot for 16:9. But we'll work on that in a minute when we're actually setting it up. Can you find it?
There's my fantastic mark in the middle of the screen.
There's one over here, bud. This is dirty mark here.
That's one dirty mark. Now where is that mark? I know I made it.
Well, let's measure it again.
Ah.
It's 2640, so it's 1320 up. 1320 is right. There. Tape.
And pen.
Yeah, is that handy? Yep. Matthew. Okay. You might think, oh, why are we mucking around finding the centre? You'll find out in a minute because it's reasonably crucial. Now let's try and do our diagonal corners and we'll figure out whether the projector's actually in the correct spot in relation to the screen. We actually had to clean Matthew's projector before it was filthy, so I have to get rid of the vacuum now.
It wasn't very clean. Mind you, I don't live in a very clean place.
Yeah, right. Okay, corners to the projector sides. So if we have a look at this now. 35-30 to that corner. Let's do this corner. And it's 35-75 on this side, which means that it's not quite square to the screen. So we'll just move his table slightly and remeasure. Might turn this off. It'd be terrible to drop the tape on it and blow it up. Okay, 35-40. Right, 35-65. I'll just pull this across a bit. I like to get this.
Oh, you might just, that's it, slide the base. That's it.
Millimetre perfect. Because if this is wrong, it won't matter what we do later, it'll never be right. And we'll end up using a lot of convergence correction to fix it. 35-60. 35-65. Push it back over slightly.
You can just shunt that base if you like. It's not locked onto that base, it's just resting on that base. That's it.
Oh, I see. That'll probably do it anyway. $35.63. I think this will be about perfect now. 35.63. Okay, so we're perfect to the millimetre. Okay, now we've got a mechanically perfect setup. So we're square to the screen. The only thing we haven't checked so far is the actual projector height to the screen for a 16:9 picture. That's going to be a little bit involved, purely because, as I said, for 4:3, the bottom chassis of the projector is going to be level with the bottom of a 4:3 picture. Of course, we've got 16:9, as I said before, so we're going to have to figure out a way to actually find out where the 16:9 picture is going to be on the screen, the bottom of it. So what I think we'll do first, the next step, is to actually set the tube toe in. Now when we do this, we forget about the blue and forget about the red. There's absolutely no point aligning anything that has to be adjusted. The only one that has a fixed position on the projector chassis and we know is square to the screen is the green. So what we'll do is we'll turn the projector on, and before we do anything else in terms of setup for this, we've actually got to zero every single adjustment in the projector. The default setting on a 1292 is a digit 128 on every screen. So what I'll do now is, and this is going to be a bit of a painstaking process, so we might stop recording while we're doing it, but basically zero every single adjustment in the projector to show the default of 128. We'll turn off the...
Sorry, Graham, do you just want to give people an idea of how to get into the old service menu? I know there's a few people get caught on this one.
Okay.
We might as well do it.
With the 1292, the default setting for startup is with a warm-up screen of 30 minutes. Now, we all know that when you have white fields or any picture at all on the screen for that matter, the any white field is going to actually wear the tubes. So, look, it's a personal opinion. It takes roughly 20 minutes to 30 minutes for the projector to actually come up to temperature and for all the circuitry to be stabilised. So, if you're not worried about tube wear, leave the tube warming function on. Within the sub-menu you can actually get to it. You can turn the white field screen off so that it actually disappears straight away when you turn the projector on. I tend to sort of leave mine set for the normal 30 minutes warm-up, but you hit the page key and that actually turns the warm-up screen off early. It actually tells you on the screen exactly what's going on with that. Now, to get into the setup menu, there's the remote. Of course, you hold down the test key. You hold that down, hold it down. Actually, I've got to push it point it at the remote, so you'll just have to bear with me. I'll hold down the test key. Actually, already in it. Right, you hold the test key down for about 10-15 seconds, and then it'll actually prompt you and it'll say push the up arrow key, which is the top one, to get into the service menu. So if you push the up arrow key, then you'll be able to actually get into the service menu like this, and you'll be able to page through the different test patterns that are inside the projector. So if you push the test key, the first cab off the rank is the crosshatch, is the centre cross.
And of course, Graham, we're going to have to reduce the light in the room a bit so that we can see those on the video.
Ambient level's a bit, ambient light level.
Naturally enough, with the 1292s, of course, you really do need to have full blackout in your cinema to be able to see it properly.
Well, any CRTs, that's the case.
Oh, that's true for any CRT, that's right.
So as you page, can you see the screen trace all right on there?
Yeah, the screen trace is coming through okay.
Now you can notice we're all out of focus, but for all intents and purposes it doesn't really matter. So if we page through the test screen by pushing the test button, we get a dot field, we get, where are we? I'll go back to the start. It's a bit hard because I'm not pointing the remote at the, there it is. So the first cab off the rank is the centre cross. I'll just roughly set that for the moment. We're going to come back to that a little bit later. Okay, if you push the test button again, you'll get a crosshatch. If you push it again, you'll get an inverted crosshatch. Then there's the dot pattern. We use this one. And then there's the focus pattern. I'll just turn off the red and the blue. You can see there that that's the focus H pattern you hear people talking about. Then we get clear fields. So we've actually got a clean field of green on that case. And we've got what amounts to a pleuge. A pleuge is, where are we? Let's see if we can find it. You can't see it with the camera. But what a pleuge is basically a couple of multi-level black blocks. One of them's meant to be down underneath black and the other one's meant to be sitting on black. It's a little bit difficult to see, but I'll just see if I can increase the contrast a bit. Yeah, it's still not visible on the camera, but nevertheless it allows you to set the black level based on what's in the projector. And then we're back and we cycle through them with the test key. So, right, now, the issue that we've got here is we don't know if the projector's at the correct height for the screen. Now, Matthew's room's not overly tall, it's probably about 7'6" at the absolute most. The problem that we've got now is that we don't know exactly, apart from for a 4:3 picture we know the bottom of the projector's level with the bottom of the screen, but for 16:9 we don't really know. How we've got to figure this out is, do you want to just stop the tape, Matthew, because it's going to get boring. I'm just going to reset this back to 128 so that every single adjustment in the projector is set back to default.
Maybe, Graham, if we just show how you reset one of the settings and then explain that we're going to do it for all of them.
Okay. Well, look, the issue here, we've got the actual series of buttons that are across the bottom of the remote. There's size, linearity, skew, bow, key, pin and zone control. Now, funnily enough, they're actually left to right, they're in the order that you actually adjust the, or do all the adjustments in the projector. So what we're going to do is we're going to set every single adjustment in the projector back to 128, which is the default setting. So what this will let us do, I'm just going to turn off the blue and the red so that you can see it a bit better. We'll set the horizontal and vertical back to 128. And we're going to do this for every single adjustment for every colour.
Now there's another way of doing this, isn't there, Graham?
Yes and no. The difference is that it sets it for the factory defaults. Now the factory defaults are stored in the memory card on the actual CPU card. Now Sony are able to, at the factory, actually store factory defaults, which are not necessarily the centre positions of the data. So if they've gone through their initial setup process at the factory, what they're actually done is they've actually stored what they believe are the correct default settings for the projector. Well, that was fine over 10 years ago when they made the damn thing, but I'm sure it's a lot different now. So we've got a whole heap of tubes here that are probably being changed, I don't know how many times since the projector was made. So what we're going to do is assume that whatever values they saved in the firmware on the projector is basically rubbish.
Right, so we're going into 128 for everything.
So absolutely everything.
So as you can see, Graham started that, and we'll come back to this process when he's finished all of them.
After 15 minutes of furious button twiddling, we've reset every zone position back to 128. We've set bow, linearity, skew, everything back to nominal, which is 128. Now what I'm going to do, you've obviously, when you've got no input into this projector, the test pattern generator that's inside basically syncs to video frequencies. Now for all intents and purposes, when we start to set this up, that doesn't matter, but it becomes critical a little bit later. Now that we've reset this one memory block, which is the video memory block, to 128, what I'm going to do is hold down the memory key. We'll save that one, we'll save it into the video memory key, into the memory block. Then I'm going to hold down the memory key again and just keep holding it down for about 15 seconds. Then you get an input screen that says this. Now it says registration data is going to be used as standard for all inputs. So what we're going to do is OK that. We're going to push the up arrow, which is the yes function, and it's actually saving the data into all of the memory blocks in the computer's CPU. Now you might say, alright, what are these memory blocks? Well, with the 1292, it's got a fairly basic memory structure, and what that means is that depending on what scanning frequency you send into the projector, the actual projector itself allocates memory block, which might be a scanning frequency from typical video scanning frequency at 50 Hz and 19 kilohertz. It has a range from 19 kilohertz to 30 kilohertz, which constitutes one memory block. Then it has a memory block, which is Regi block 2 they call it, and then it might go from 30 kilohertz to 40 kilohertz, and this will go up. I can't remember the exact number of memory blocks for it. I think there's about 10. It's how many? 5, 6, 7, 8 memory blocks, depending on scanning frequency.
Yeah, I think it might be 8.
What I'll do, I'll just page through here. If you push the page key and you keep pushing it, you actually get to the end there, and I'll do it again. And it actually tells you which Regi block this is in. This is in Regi block 3, so this is 3 of 8. So depending on what scanning frequency goes in, you'll actually get a different memory block. So what we've done now is, after resetting everything to 128, we've gone ahead and we've copied that 128 figure to every memory block in the machine. So we're now truly back to scratch as far as the machine's concerned. So we'll just exit this off by pushing the memory
Just
block.
want to go through those menus, Graham, just quickly.
Page menus.
The page menus for people that don't know where they are.
I mean, there's no great mystery here, but we can do it anyway. Status is pretty straightforward. You'll see there's a status key here at the top of the machine, at the top of the remote. It's got status on, status off. Basically, it kills this these pre-done menus so that you can't see them. I don't really know why it's there. It doesn't really accomplish a lot. Picture muting off, there those orange buttons, you've got picture, audio. If we go to the next page, basically these are where your contrast and brightness controls are. These colour, sharpness and hue adjustments will only work on the video input. So when we're using RGB or component input cards in the slots in the back of the machine, the only adjustments you've got are contrast and brightness. Go to the next one. This is actually the colour temperature. There's preset colour temperatures inside the machine. Let's try. There we go. Right, it's 9300 degrees Kelvin, which is sort of a fairly, if we put a white field up on the screen, 9300 Kelvin is sort of a bit of a bluish tinge. A lot of computer monitors use 9500 degrees C or 9300. 6500 degrees C is widely seen as being daylight. So for all intents and purposes, when they expose film, when they do video, they tend to use 6500 degrees Kelvin as the colour temperature. That's meant to be the temperature of the light, the colour temperature of the light on a bright sunny day in the middle of summer, somewhere in Europe somewhere. I think that's where they came up with the standard. 5400 and 3200 really we don't ever use. This is very red, this is extremely red, so we're looking almost different shades of white, a bluey sort of white, a sort of neutral sort of white with a very slight red tinge for 6500. These are very red, that's extremely red. For all intents and purposes, we'll only be using 6500 degrees Kelvin because that's what video and film is shot at. Right, when we're actually applying an external sync signal, you might have a HTPC that you're feeding into it. You can actually read the scanning frequencies off these areas when you've got an input signal. At the moment we've got no input signal into the projector, we're just using the internal test pattern. So of course we've got no input signal, so we can't have any vertical and horizontal sync frequencies displayed. There's the actual internal oscillator frequencies at the moment for video. And these ones here, this is the CRT timer display. Normally, if you haven't gone into service mode already, this CRT timer mimic display here doesn't come up. Right, it's only when you go into the service menu that you can actually see how many hours the machine's done. If you go into here and we're on number 1, if you push the right arrow key, it'll actually show you the number of hours on the red, green and blue tubes. But it'll only do this in service mode. So, 2,117 hours, Smash, yeah.
That's me. And
board rate display, I've never used. All it's to do is it's some sort of data interchange controller thing that's meant to go in the RS232 port in the back of the projector. You can pretty much ignore that. Okay, now this is going to be the really sticky part because in order to set the projector up properly, we've actually got to maximise the rasters on the face of all of these tubes. Now you think, oh, why are we doing that? The issue is, with the tubes that are in these projectors, Sony projectors are a little bit unique when they have Sony tubes in them. NEC tubes and MEC tubes that are used in the G90 and also in the G70 have a different shape bell housing on the back of the tube. I haven't got a tube to show you actually, but basically the Sony bell housing is a big wide open tube that looks like a bell, shaped like that. An MEC tube actually has a very triangular tube bell. Now there are reasons why a lot of NEC people don't run rasters right to the edge of the tube, to the edges of the tube. We're all in this to try and maximise the amount of light we put on the screen by making the raster as big as we possibly can to take up as much of the phosphor on the front of the tube as we can. With an MEC tube, that's not possible because the actual beam current, the beam that runs down the length of the neck of the tube, if you open the scans out so that you've got full width raster on the screen, on the tube face, it actually hits the corner of the tube bell, and there have been a lot of failures in G70s and a few other projectors where the tube will actually break due to the impact of the electron beam on the side of the tube neck where the beam gets opened out onto the tube face. So typically NEC users will run probably a fair distance in from the side of the tube. Sony tubes, on the other hand, because of the shape of the tube bell goes like this, they don't have that limitation. And yet with a Sony projector with Sony tubes, and some of the early Barcos that had Sony tubes, you can actually run the raster all the way to the edge of the screen with no ill effects at all because of the shape of the tube bell. So what we're going to do now, in order to figure out what the height of the projector has to be relative to the screen for a 16:9 picture, what we're going to do is get the remote, and while we're looking into the lens, we're actually going to open the scans up with the size control on the remote, only on the green, so that it takes up the majority of the width of the screen face. Okay, now what we're going to do is we're going to try and maximise the raster on the tube face. Now, right at the moment, we don't care what's going on with the red and the blue. So what we're going to do is cut off the red and the blue tube. The only tube we're interested at the minute is green. So if you can see up in the top right hand corner, now that we've zeroed all of the adjustments out to 128, you'll see you've probably got an extraordinarily pin-cushioned image, and the sides of the actual scans are probably square to the tube face. Well, we all know that the actual exposed area of the raster on the tube face on a normal CRT projector isn't square, it's a trapezoid. When you've got it sitting on a table, in order for the picture on the screen to be square, the raster itself is going to have to be a trapezoid shape. So what I'm going to do, now that we've zeroed everything, I'm going to get to the pincushion control, and I'm going to actually square up the actual raster itself. None of this is done with a test pattern on, by the way. It's only done with the raster, which is actually increase the brightness up with no signal, and you'll get a bright outline of the low level without having the test pattern on. So what I'm going to do, we've just increased the brightness right up to maximum, so we've got a nice bright square on the screen. We go to pincushion. Now I'm just going to have to get in the way while I do all this.
The corners,
the corners, the tube sides.
Okay, we're looking at the corners. That's bottom left, and that's bottom right.
Now you see how the sides of that, now I've fixed the pincushion correction, and now square to the sides of the square tube. So we'll just use the pincushion control for the moment to get it right. Now you're aware that on the screen now this is going to look like a trapezoid because we haven't put any keystone correction on the tube itself.
So if I swivel round now and show you what we've got on our screen, of course, you'll see that I've got, well,
a trapezoid.
A trapezoid.
Okay, but we can tweak that out. But right for the minute, we're not interested in what's on the screen. We're actually trying to centralise and maximise the size of the raster within the tube. So now we push the size control on here, and we actually push the arrow keys and open the scans up so that they're all the way to the edge of the tube, or within a very close proximity of the tube. Now, okay, you can see the sides are really close to the edge of the tube now. That's probably close enough, there's no point going any closer than that. Alright, that's good. So the next thing is, it's not on the left and right, it's not perfectly centred, and of course it's not centred between the top and the bottom corner of the tube. So what we do is we push the zone control on the remote and push the green adjust button. Now what the zone control actually do, it'll actually let you move the centres. So what we're doing is looking at the raster, which is the sort of the bright outline, and we're moving it so that it's the same distance from the top of the tube to the top of the raster as it is from the bottom of the tube to the bottom of the raster. So now when you look in there, we've actually got a bright raster centralised within, right in the middle of the tube face. And you think to yourself, okay, that's great. Well, there's a reason that we do this on the green. So number one, so that we know exactly where it falls on the screen itself. And actually on Matthew's screen the image is a fair bit higher, which means his table's a little bit high.
Oh, good.
Yeah.
There's going to be a little bit of off-camera work shortly with my table.
So what we do, we've done the green.
I'll just show you what that looks like. You can see that there's a gap at the bottom of the screen,
and we're overshooting on the top.
And we're overshooting on the top.
We can actually fix that in one of two ways. We can actually tilt the bottom of the projector up, the back of the projector up, so that it actually pushes the image downwards. But we don't want to change the position of the image on the actual tube face. It's in the middle. It has to stay in the middle, because if you push it off to one side or the other, what you're doing, every lens has what's aberrations in its construction, and generally those aberrations, which are to do with the lens grinding, tend to get worse as you get towards the edge of the lens. Lenses are round, the tube face is square. So if we translate the actual raster upwards so that the picture on the screen moves downwards, what's happening is the top and the left and the right corners of the actual of the raster on the tube are actually getting very close to the corners of the lens. So any aberrations or distortions that are in the lens right on the corner are now in your picture. So what we're trying to do is to fit the raster in the exact position, central position of the tube, and then therefore that means that the actual raster is being projected in the exact centre of the tube. So any aberrations in the lens are not as bad on the corners as what they would be as if we translated them up and down on the tube face. Okay, so where we are now is we've got the green raster centralised on the tube, and what we're going to do now is do the red and the blue, and in exactly the same way that we've done the green. Forget about what's on the screen. All we're worried about is what's on the tube face. So what we can do is pause the tape now, and I'll go ahead and set these in exactly the same spot and size and position as the green.
Graham, just before you do that, let's give them one more quick look at the green raster on the 1292 in its final positioning on the corners, and we'll just show that in relation to the tube. We'll try and show you that the raster is taking up as much space on these tubes into the corners, and it's centralised with regard to the tube face. I don't know if you can see that.
That's pretty good.
That's pretty good. Well, that's as good as we can see it. You're seeing it, and that's what you work with when you're trying to set this up yourself.
Yeah. This is not quite as easy with liquid coupled lenses as well, or liquid coupled tubes, because you can't remove the lenses and do this. You actually have to do it while looking into the lenses. On non-liquid coupled projectors, you can remove the lenses and move the raster around quite happily and do it without the lenses on. It's impossible to do it with liquid coupled. Okay. Interesting thing about setting these tubes up in all three colours, you want to make sure that everything's in the same position on the tube face for all three colours. But what you can do, if you stand back a little bit and look into the lenses, you can actually scribe a line directly across all three lenses so that you can see the tops of the rasters in all three tubes at the same time. And you can actually adjust the height and the vertical positioning so that you can see all three at the same time, and you can actually scribe a line across so that you know that they're the right height. So if you look at you do that at the top and you do that at the bottom, then the only place that you've got to be concerned about the positioning is horizontally across the screen. Right, now that's done, you're thinking, alright, well that's fantastic, why the hell have we done that? Well, I'll tell you why we've done it. We've got to do the tube toe in. Now what the tube toe in does, if we look at the screen now, and this one's actually not too bad, when you look at the test pattern on the screen, all the green lines, the lines themselves, these parts here, what we're actually doing is adjusting the actual red and the blue tubes so that the centre of each of the tubes is set up to the correct position right in the centre of the screen. So you can see here, if this was set up properly, the green one's the reference, remember, the red is not quite over the green. It's pretty close though, and the blue is a fair way out. So what we've got to try and do, forget about the horizontal lines, only look at the vertical lines. We know the rasters are centralised on the tube faces. When you put up the test pattern, it puts the test pattern in exactly the same place across the tube face on all three tubes, and this is how we tell whether the tube toe-in's correct or not. You can see here the blue needs adjusting. Okay, now we've got the trusty Allen keys. We've got to set the tube toe. Actually, I'll just do this again because it's actually muted itself, but we're up. Here's our crosshatch back on the screen. Now what we're actually going to do is rotate, I'll go over here, is rotate the tubes inwards or outwards as need be, so that the actual centre of each of the tubes is right in the middle of the screen there. We know the green's right. These are the adjustments here. These two Phillips head screws, one on the red, one on the blue. So we're actually going to undo those bolts. Now a word of warning too, because these probably haven't been moved since the damn thing was new, they can be really hard to move. So basically, we grab hold of the lens like that, and actually, this one's one of the tight ones. The reason I wanted the Allen key was because these are usually frozen up, so these are the actual mounting adjustment bolts.
I have to confess at this point, Graham, that this has been undone and I have played with it prior to your arrival.
Okay.
But I haven't undone all of them. I've only undone...
We only got to undo two, and we only have to loosen them off enough because sometimes they freeze up in here. Now, in order to get this right, that's what these three holes are for here. These are so to let you prise the actual tube in the direction you want it to go. So I use my Phillips head screwdriver, so I stick it in there and actually rotate it, and what that does is it levers the blue gun around. Just see how we go here on the screen. That still hasn't moved enough. So I might do that. Put it in the middle hole. Now we're looking. It still hasn't moved much. Just hang on a sec, because I can't. You're standing with the camera right in the middle. So just have a look at the screen for a sec, and you'll see if I lever the blue across, you see what it's doing. It's actually moving the tube. So what we've got to try and do is to lever that across like that until it's directly behind the green tube. Try not to use a magnetic screwdriver like I am, because as soon as you reckon you got it right, it actually zips back where it was before. I'll just give it a little bit more of a tweak. Okay, so now you can see there that the blue is directly over the top of the green. I only worry about the vertical because the horizontal doesn't really make all that much difference. I'll just lock that back up. Tighten this. I'll do the same to the red. Just preempt this by undoing them anyway. Sometimes you need to do this, sometimes you don't. The red's actually not out all that far. You'll find if you've got a magnetic screwdriver, when you do this, it'll be all over the place.
Let's have a quick look on the screen. As Graham's moving that around, you can see the red's now coming back into alignment.
That's my magnetic screwdriver. There we go. So the centre spot, you can see there that the red is pretty much directly over the top of the green.
It's interesting to see, Graham, it also shifts slightly once you put the...
Oh, that's my magnetic screwdriver, look.
So be warned, if you're using a magnetic screwdriver...
It'll be right, and then as soon as you take the screwdriver away, it'll be wrong again. Now, actually this one isn't too bad. Now remember how I said that we've got the scans mechanically right in the centre. Now this is the real gooey part, and for this we'll probably have to turn the projector off. We now know that we've got our toe in right, so that's good. We'll put the crosshatch up and see now it's pretty much all up the put. But what we need to do, remember we've centralised all of these adjustments. We've centralised the skew, we've centralised the bow, we've put it all back to 128. Well, the problem that we've got now is we want to keep these adjustments in the middle. But you see here the green, the red's actually lower than the green, the blue is lower than the green, and over this side it's significantly different. And we can do one or two things. We can use the electronic controls to fix it, or we can actually undo the yokes on the back of the necks of the tube. Now, depending on how far out it is, this is actually not all that bad. We might just use the electronics for this. But if you've got one that's grossly out and you've reset everything back to 128, you have no alternative but to rotate the yoke of the tube, which is the big coil assembly right behind the tube bell. Now,
Graham, would it be worthwhile just showing that in
I'm going to do that because I know this one doesn't actually need it because it's not that far out. So what we'll do, I'm going to actually at this stage, I'm going to turn off the red and the blue tube, and I'm just going to roughly set the geometry of the green. Now we know that the keystone correction, I'll turn the red and the blue back on. We know we're going to have to use, we know we're going to have to use some keystone correction to get this right. You can see there now we've sort of roughly got it right. Quite a bit of keystone correction actually, which is interesting. Now if we put the red back on, it actually does all three colours. So here we are now, we've got our crosshatch. We've got our sides roughly vertical, only has to be vaguely vertical. You can see there that the green is not quite right. Now I'm just going to jump ahead a couple of steps because what we need to do is to make sure that this green, the green test pattern is in fact vaguely straight and square. This is a little bit of a shortcut, but it's probably needs to be done at this stage. If you have a look at it, you'll see that the horizontal line's got a bow in it. So what we're going to do is just quickly set the bow up so that that line in the centre is vaguely straight. Doesn't matter if it's warped or skewed one way or the other, as long as it's vaguely straight. Now we'll use the bow adjustment on green only to do this, and we'll get the vertical line vertical, and we'll get the horizontal line straight. So you can see there now we've got a horizontal green line that's sort of pushed off to the left a little bit, and we've actually got a green line that's tilted upwards on the left hand side. So what we've got is we're actually set with a tube that's not actually square. So what we're going to do is I'm going to undo the screw on the tube neck. This is not for the light-hearted, especially when the projector's going, but for the purposes of this I don't really want to turn the machine off to do it. So I'm going to lift the back flap up. Right, you see, actually I might turn the tube off, turn the projector off just in case we blow something up. So I'll turn the projector off. We know that we've got to actually rotate the yoke to the left to get the horizontal line straight and the vertical line more vertical than it was before. On the tube neck, I was talking about the yoke before. This is the yoke assembly here on the back of the tube. This is the deflection coils that direct the scanning lines across the screen. This screw here, that one, is the actual clamp that holds the yoke onto the neck assembly. Okay, so what we're going to do is we're actually going to loosen that as soon as I'm happy that the high tension's dissipated a little bit. Put the screwdriver in there, we're going to loosen that off. Just about 5 or 6 turns so that we know it's loose. I'm just going to wait for a minute because it's high tension still crackling inside. all of the high tension crackling seems to have dissipated a little bit. It's been a couple of minutes. Now what happens is, because these have probably never been changed for the whole time that the projector's been used, they tend to get a little bit gooey on the yoke, and they can be hard to move. So if you loosen it off and you grab hold of that plastic thing, you might actually have to move it backwards and forwards like that a fair bit just to make sure it's loose. I can actually tell you that this tube has never been out of this machine, because you see that grey stuff there, that's typical Sony sealant for the astigmatism adjustments. This tube's never been touched before or adjusted since it was new, which implies that it's probably going to be a big improvement when it's fixed. Okay, so now we've done this, what we might do is undo these on all 3 tubes, and we'll just loosen them for the minute and make sure they're free. Alright, that one's okay, and we'll do the red. And make sure that one's free. Oh yeah, that can be turned. Okay, so now what we've done is we've loosened all of the yokes off. We'll turn the projector back on. Never stick 2 hands into a projector that's running. You always do all of these adjustments inside, around the neck boards, around the yokes. Do it with 1 hand. Never put both hands in there. Okay, now we put our crosshair back on. Have a look at that on the screen now.
Oh, that looks perfect, Graham.
Yeah, that's
much
straight.
better. Excellent.
So what we'll do is we'll actually turn...
Nothing like bringing the experts in, is there?
Mate, I'm off now. So we'll turn off the blue, we'll turn off the red.
Come on, you better come now, right now, right now.
Okay, we'll just rotate this until we get the crosshatch perfectly horizontal across the screen. So what we're going to try and do is find a position where we've got the minimum amount of adjustment on both axes. So if we go to the remote now and push skew, right, on green, you see we're all set for 128 in the corner. We're actually going to push the horizontal and vertical keys so that we can straighten up the horizontal or the vertical line as straight as we can get it with the minimum amount of adjustment. That might mean you have to go backwards and forwards between the 2 until wrong way. Until we get a position where we've got the absolute minimum of adjustment to get the actual test pattern horizontal on the screen. That's probably about right. At this stage, what I tend to do is measure both sides of the screen so that we can actually ascertain that we've got that crosshatch. Where did that tape measure go? Perfectly vertical. That's 940 on that side, 950 on that side. It's not quite right. It should be fairly close.
Normally the assistant does this bit.
Normally, but he's holding the camera at the minute.
But the assistant's holding the camera, and the assistant's dad said it's lunchtime.
Okay, so we've got 945 on both sides, so at least we know that that's horizontal. We look at this one and we go across, we know that's 1350. Come across a little bit more. The good part is that we only really have to be all this critical on the green, because the other colours just have to match the green up. So once we've got that right, and you see now we've got 163 on both axes. Once that's done, we can save that into memory by pushing the memory key once. what we can do is actually tighten the yoke nut back up using our nicely insulated screwdriver and being very careful. Okay, you don't have to crowbar this up a lot, just enough to hold it in place. Okay, so now we've got our horizontal and vertical green scans perfectly centred on the screen.
And Graham, I think that's time for our lunch.
Yeah, that's it.
Right.
Let's eat.
Let's eat.
So now we've got our green right, we've got our green horizontal, we've halved the difference between the horizontal and vertical skew, so now we've basically got a straight green line horizontally and a straight green line vertically. Now of course we've got to do the other colours now. Remember we've set everything back to 128, so now we get to adjust the red.
So I'll just show how you're moving that.
I'm actually twisting.
Let me just see if I can get in there, Graham. That's it.
So you can see how much it moves. Well, that's actually changing the scans on the
Now
screen.
I'm going to get you to keep doing that while I show what that looks like when you do it on the screen.
Alright.
Okay.
There we go. So you can see there it twists it. So what we're going to do is we're going to get, you see there the vertical, I'll actually turn the blue gun off because that's just confusing the issue a bit. So you can see there's the red and the green. So we can either get the red horizontal one straight or the red vertical one straight. So what we'll do actually, I think what we'll halve the difference between the two so that we use about the same amount of correction. Now just keep in mind too that we're only doing this initially so that we can get these deflection coils in the right spot. We haven't even started to do the astigmatism yet, so we're just going to get these right so we don't have to change them. I'll just tighten that coil back up. Okay, so that deflection coil's done. Now we'll just turn the red off now, and we'll turn the blue on, and we'll adjust the blue in exactly the same way.
Might be a better shot from here, from this side, if I show.
Okay, well there you go, there we are moving the blue relative to the green. So we know the green's right. So what we've got to do is find a spot where the blue and the green are roughly the same amount of correction to get them right. This is difficult. We all know that blue's harder to sort out. So what I like to do is halve the error between horizontal and vertical so that you've got about the same amount of correction in both axes. And that looks pretty right. I mean, our vertical's not super vertical, our horizontal's not super horizontal, but we have got some correction to be done for that electronically, so that's fine. So we'll tighten that coil back up. Okay. We know that our scans are correct on the front faces of all the tubes. We know that the cross hatches are parallel and that the deflection coils are in the right spot. What we have to do now is probably one of, not the most difficult, but probably the most misunderstood thing about these projectors is the astigmatism. What's astigmatism? Well, what it actually does is it uses the deflection coils that are around the neck of the tube to actually modulate the beam in a way that can change the physical properties of the way that it scans. If you can just have a look at this green tube here, that there, this grey box on the back of the 1292, that's actually the electronic focus coil and astigmatism coil. See all of these wires here, some of them are actually for electronic focus, some of them are for the shape of the beam spots. There's probably a good dozen and a half wires there. Now really the electronic part of this adjustment, apart from focus, all it really does is you use it to change the shape of the dots around the outside of the screen or the shape of the crosshatch, or difficult to explain. But the interesting part about this is only really does the edges. It does the magnetic focus overall, but it does the edges. These here are the actual astigmatism magnets. Now you can see there's two handles. Ow, that's jumped at me. Be very careful. These handles that you can see here, there are two functions. They actually rotate. You can see that one's actually sliding now. That's one. And if you have another look, you see it's actually a handle, and you can actually rotate that, and that changes the shape of the beam as it goes down the length of the tube. Now there's two of those. It's a 2-pole magnet system on the 1292. It's not a 6-pole, which is like some of the NECs. I never find I have an issue with this, but some people reckon that there's a problem with dots. I can always get the astigmatism perfect with this system. Okay, now we've sort of roughed out our picture on the screen. The next thing we've got to do is set the astigmatism on all 3 tubes. I mean, this is not necessarily a big issue, but it's difficult to get correct, and this procedure will probably take the longer and be the most critical of any of the ones you're going to make on the machine. If this isn't right, you can kiss 1080p goodbye. One proviso that we've got for this, for setting the astigmatism accurately, is that we have to use high scan rates. Now, at video frequencies, it's neither here nor there. I mean, it's very easy to set the astigmatism at video frequencies, but when we start getting up towards 1080p, then we've got a real problem. All of the dot size on the screen is critical because we're trying to get high resolution. Also, small adjustments on the handles of the astigmatism magnets have a much bigger effect at 1080p than what they do at lower frequencies. So basically, to optimise the entire thing, we have to input a 1080p signal or higher into the projector, so that we've got enough accuracy to actually set the astigmatism correctly. Interesting thing that you may or you may not know, on the 1292 and most of the early 12 series Sony projectors, the internal signal generator actually syncs to external signals. The purpose of feeding it with a 1080p signal is to allow the projector's internal test patterns to sync up to as high a resolution source as you're going to use. So if you had a scala at 1080p or a HTPC with a high scan rate over 1000 lines, you pretty much got to put that into the input so that the projector's internal test pattern, which is what we're going to use for all our adjustments, can sync up to the external signal and take on the high resolution number of lines. So Matthew's just plugged in his Lumagen, which is putting out a 1080p 50Hz signal. So what we've got to do now is adjust the astigmatism on green. We'll do green and then we'll do red. Now, before we go ahead and actually touch the astigmatism magnets, we'll just actually go quickly to the magnetic focus menu. Right, Matthew's remote isn't actually a 1292 remote, it's for a 1272. But on a 1292 the remote is basically the same, except there's a magnetic focus button just about here. So what we're going to do now is just quickly do the magnetic focus, which is for the centre part of the screen, just so that we know that it's vaguely right. So we'll just energise the MG focus fact on green. And I'll just give this a quick tweak because it was a little bit far out, a little bit fuzzy.
Graham, can you just tell me what you're tweaking here, what you're looking for when you do this?
Well, what we're doing, when you use the focus adjustment on these things, this H pattern that's on the screen, you think to yourself, oh yeah, I wondered what that was for. Waste of time using dots, because when we get into the MG focus menu a little bit later on, after we've done the centre astigmatism, you actually have to use this. You can't use the dot pattern, which people seem to think that you're supposed to use to set the astigmatism, the electronic astig in all of these corners. It just doesn't work. You have to use the H pattern. So what we're doing here is basically focusing it against the H pattern, whereas you see green all, G all, you're actually just focusing up the parts in the centre. And it does affect the focus overall, but for the purposes of this, just get the focus right in the centre. And do the lenses at the same time, just so that you know it's vaguely right. Okay, and we'll just store that. The focus data is independent of all of the memory blocks, and so is the astigmatism data. Okay, now just getting back to this. Now there's two types of astigmatism adjustment. If we can just have a look down here, Matthew. There's two handles. There's the front handle and the back handle.
Hold on, let me get down there.
All right.
Here we come.
There's the front handle adjustment and there's the back handle adjustment. There's two, because what we're doing is actually setting the flare and setting the astig, and you say, oh, okay, what's flare? Well, I'm not going to go into too many heroics about explaining what they are. What I want to do is show you how you adjust them. So there's two handles here. What we do is hit the test signal. The first thing that we're going to do on the remote is we're going to put the dot pattern up on the screen.
Hold on, I'm just going to come back to that now.
Okay. You can see we've now got our dot pattern on the screen.
Right.
Now, you're in the focus menu. Actually, we might turn the lights down a bit, can we?
Yep, we'll pull the lights down a bit.
What we've got to do is defocus. That's better. Is defocus the. Right. Is defocus the central dots on the screen, and you'll see. If you have a close look, it might be a little bit difficult to see, but in one direction you'll end up with a blob with a very bright centre.
Hang on, we're coming in on a blob now. Right,
See, it's got sort of a bright centre, but it's a bit odd looking, odd shaped.
Right.
Okay, now if we focus in the other direction, see how it goes sharp, and then it goes out like that, and you see,
yeah,
the idea here is that these dots are meant to be round. Now, if we just look back for a minute, you see how they're egg-shaped. We go back over here to the astig magnets on the back of the projector on the tube. The two handles that are on the back of these.
Hang on a sec. I'm going to use high technology.
Oh, the torch.
The torch.
This handle on the back actually sets your sets the shape of the dots. So what I'm going to do, there's two adjustments. There's
I'm just going to come in there a bit. Just hold on a sec,
okay,
Graham, while I try and give people a clear picture in there of those handles. Right, that's
There's
it.
backwards and forwards,
yep,
like that, and you can go halfway around the neck, but you can also twist the knob like that. Some of these that have been sealed up for a long time with this silicon, you actually have to pick the silicon off because it actually sticks onto the tube really good, and sometimes it clogs up down in these little gears. So anyway, look, just looking back at this now, let's have a look.
Now you're playing with the back one, aren't you?
No, at the moment we're doing the front.
The front one.
The
right,
front magnet. What this does is it sets the shape of the dots.
Alright, well look, I'm going to go back onto a dot.
Okay.
While
and
you're
I'm going to move this backwards and forwards
while you're
and twist
playing
the handle. So I'll actually twist it like this.
I'm going back onto a dot in the middle of the screen now.
Okay.
There. Now.
And if I twist that handle, you see how it makes the dot go oval?
Well,
this is a combination. If you twist the handle, it changes how oval the dot is in the direction that the dot goes. You see that?
Yep.
But if I actually rotate the shaft around, see what it does? It
yep,
actually turns the sharp end of the dot round. So what we're trying to do is we're trying to find a spot where the actual dot itself is round.
Yep.
Now, if I get the remote, I'll just try and defocus this a little bit more. Well, it was actually defocused the whole way. Okay, now it's a little. Have you got a close up of the screen?
Hang on, I'm going in a bit closer for that, so that people can see that dot. In close up. Okay, now try it.
Okay, so I'm twisting the handle, and you can see it makes them sort of into lines. If I go back the other way and twist the handle, it makes them into tall lines. So what we're looking for is a spot in between where the thing's actually round, and in between this it's an interaction between the actual rotating of the knob and the position of the magnet around the tube neck. So a little bit difficult. If you think the green's difficult, the blue gets worse. So basically we're looking close and we're coming up and having a look and seeing if the shape of this is very dotty.
It certainly looks like a dot now.
Yes. So we've got to try and optimise that so that it's as close to round as we can possibly get it.
Sorry, I've just played with the settings of the camera trying to get it a bit better, but I can't.
Never mind. Much we can do about it. So they're reasonably round now. So
just go to the dot below that is the one we're looking at.
This one?
Okay, that's, yeah.
You pick one in the centre of the screen, so I'll pick that one. It could just as easily be that. And just remember, you're only setting the middle. Forget about the edges right at the moment. We're only doing...
Now I'm just going to come back down now to revise that astigmatism setting on the camera.
So we've actually ended up with it here, and with the handle rotated, what it's doing, it's actually sliding a pair of magnets around the neck like this.
Hang on.
When you rotate them. So it's sliding magnets like this around the neck, and that's what's causing the beam shape to change. That's probably about as close as we're going to get the dot pattern to round. We're only looking at the middle, remember. Now if we hit the test button again on the remote, we want to go to the crosshatch pattern, which is that one.
Hang on, crosshatch pattern, everybody, it looks like that.
Okay. Now what we do now is we actually unfocus the projector and go all the way, or as much as we need to, in the opposite direction. So you see there it's gone from 0, we're now back up past 128, and we're going to go the other way. Now what that'll show you, if you haven't, it's a bit difficult to see on the video camera, but there's actually a bright line within those squares.
Hang on, I'll just come in on that for a sec. Let me see if I can focus
Very
in.
difficult to see, and particularly difficult with the camera.
It's sort of there.
Well, what you're doing with the back handle, which is the rearward one, is you're actually changing the position of the bright spot. Just have a look here. Some projectors this is really easy to see, others it's not overly easy. I'll just see if I've got the contrast all the way up. Yep, contrast is all the way up. You always do this with the contrast flat out. We're pretty right. So what we're doing with the rear handle, you can see there how it changes shape. Now the idea is, you see how if we twist the handle all in one direction, see?
I've got that.
It actually changes the shape.
Changes the shape of the
cross.
width. Yep.
And what we're trying to do is to find a position where the width of these things is roughly the same, and that if you can actually see the bright thing there, it's not too bad. It's very difficult to see. This projector doesn't actually peek out as good as what the other ones do. So the idea is we're trying to find a spot.
Let me just see if I can get the brightness in the room a bit better for you, right?
Oh, that's a bit better.
I think you'll find we're going a bit too much ambient light.
Ambient light. The green's difficult, the blue's going to be worse. So we're trying to find the spot.
Trying to do this in broad daylight, of course, is not the ideal either. I wouldn't recommend broad daylight for this, even with blackout curtains.
Yeah. So the way that we can check this is when we focus back down again, the width of the lines should reduce by this at the same time. So what you'll see is the width of the lines collapse, and then once you get past a certain point they grow again. So what we're trying to do with this is we're trying to get the line width to collapse horizontal and vertically so that they're both collapsed to the closest point all at the same time. Now, that's actually not too bad.
Let me just go in again. Right, I'm full zoomed in on that. So
I'll just defocus it. You can see that the width of the lines is pretty much the same. If we reduce them, generally what you can see, if in a little bit easier circumstance, this projector for some reason isn't quite as prominent as others, you can actually see a bright core within that crosshatch. And the idea is that bright core is supposed to be right in the middle. Now, and then so that when you reduce the focus back down again, it actually collapses back to one singular point. On this projector, for some reason, it's not particularly visible. So what we have to do is look at the way that the lines collapse, so that they both reduce to the minimum, and then when we go past perfect focus, they both increase at the same time. Now, this is all a bit of a trade-off, because everything interacts with everything else. So if we think we've got this right, then now we go back to the dot screen. Actually, the bright core is probably a little bit more visible in the dots. You can actually see they've got a bright core. The bright core this is exactly the same test as the crosshatch, but the bright core's got to be centralised in the blob. Because now that we've changed that other magnet, our dot shape's not right, so we have to go back and adjust that again.
I'll just go in on that dot. Graham, could you just do that again for me? Just.
Okay.
And I'll just see if I can get. Yeah, it's a bit blurry from where I'm at, but that's okay.
Well, it's meant to be blurry. What we're trying to do is get the dots round, which that is. So now that we've done that, we can go back. Check the other one again, and then use the crosshatch again. Let's have a look. Now, what I'm going to do, I'm just going to have a look and make sure this optical focus is pretty right. We need to check a lot of things. There's a big interrelationship between all of these adjustments. That's actually a bit better. Now, we want to check this now. Now, one of the biggest, the weirdest things that happen is because you can get this perfect. The problem is, for some god unknown reason, if I turn the red dot back on, you see there's the red dot. Now, I generally do this because it gives me a reference. When you defocus and focus, the dot is meant to stay in the same, physically in the same spot. It's not meant to move. So if you look at it as compared to the red dot, see how it's moving? Now, ideally, when the astigmatism's perfect, this dot will stay perfectly.
Sorry, Graham,
still.
could you just show exactly what you were doing there to move that dot?
I'm just changing the focus.
Right.
And as I'm changing the focus from minimum to maximum, see how the dot's crawling? It's physically moving compared to the red dot. The red dot's only there for a reference because it's not moving at the moment. But if you look at the green, as I adjust the focus on the green, you see how the dot moves across the screen?
I'm just trying to get the numbers in that you're moving and relative to the dots.
It's just from minimum to maximum focus.
That's right.
But look at the dots, you'll see that the dot, as it goes from minimum to maximum focus, is actually crawling across the screen compared to staying still. Without the red dot there, you can't see it.
No,
it's very difficult because it's not very prominent. But what it does point out is, guess what? The astigmatism's still not right. So what we've got to do is, not with the circularity control, but with the astigmatism controller, which is the rear handle, we've got to find a spot by twisting it round the neck of the tube where that green dot actually stays more or less in the same spot. That's a lot better than it was. So let's just move it a little bit again. This is a bit of an iterative process, so very difficult to do. Green's not too bad, but blue's awful. It's not much better actually. There'll be a spot where the flare is good and you can get the dot to stay in one spot. Might take a little while to get it. That's a lot better actually. Okay, well I'm reasonably happy with the way that the green dot is. If I focus and defocus this, it hardly moves at all, and when it collapses down, it actually is quite small and both directions seem to collapse till it's almost at the same point. So you can see there it hardly moves in relationship to the red dot there. So I'd say that's pretty much set. This can take, depending on how many times you've done it, you could be doing this for 20-30 minutes of colour. Some people take it even longer. I know Doug Basie does takes an awful long time on an NEC, but then again he's probably a little bit more competent than you and me. So yeah, I think that's pretty right. So now what I'm going to do is I'm going to go ahead and I'm going to do this on all three colours. Okay, well I've done the green, the blue and the red, and don't look too bad at all, but what we have discovered is that Matt's green tube has the dreaded Sony phosphor delamination problem. There was a series of green tubes that 1292s had where there was an area in the middle of the tube face where the phosphor actually delaminated from the glass. And some tubes were way worse than others, but it manifested itself by the actual phosphor pulling away from the glass and being out of focus. In some tubes it actually flaked off and you could just see this huge patch of crap in the middle of the screen. Matthews is fairly sort of indistinct, but you can see how it's sharp here and then it sort of gets out of focus about here. And there's no way to fix it because it's the actual phosphor coming away from the glass. And you can see it's in a typical big round patch right in the middle of the tube. So if you ever have a hassle with not being able to get the centre correct, that's more than likely what the problem is. The phosphor delam problem. The only way you can fix it is to replace the tube. But in Matthew's case, this really isn't that bad. It just creates a bit of a fuzzy halo-y effect on the green. I mean, my advice would be to leave the damn thing until it fails, and it will fail eventually, it's just a matter of when. While it's looking alright, I'll just leave it. Okay, so what we're going to do now is do the electronic astigmatism over the entire screen. Now, this is a bit of an effort because there's 21 positions. I think it might be 21. Could possibly be 11, I can't remember.
No, 21 I think, right?
It's 21 for convergence. I think the actual electronic astig's slightly different. But look, it doesn't matter. But what we're going to do, everybody says, oh, you know, you set the astigmatism with crosshatches and dots. No. When you're doing these edge things, you use the H test pattern that's on the that's in the projector. This one here. Oh, actually, if you have a close look now, see the dot? Look. See the out of focus dot? This is the tube delam problem. You can see the extent of the dot on there. See that? So I think that's pretty much conclusive. See, sharp, 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 and then all of a sudden, right in the middle, it gets furry. That's the Sony tube fault. But it's actually, this is quite good compared to some of them I've seen. So at least that explains the reason why we can't focus the green in the middle. Now, getting back to astigmatism. Right, now we're already in the MG focus menu. We'll select the green tube. There it is there. And this is the overall focus. And we go to the next one, which is the bottom. This lets us set the astigmatism in the bottom of the screen. Now, this actually works in two dimensions, so you'll be using the left and right and the up and the down arrows. And what we're doing is we're trying to find the most defined pattern where the H pattern will actually grow and shrink depending on how you adjust this. So the idea is to get the thinnest, narrowest, sharpest pattern by using both actually this one here is edge focus. So we'll try and do that first. We'll get the narrowest, sharpest H pattern we can get, which is about there, in just this portion of the screen. Then we flick the plus button and it'll let us do the other one. So there's two adjustments in each plane. Each of them will let us adjust to get the sharpest H that we can get. In theory, after we've been around the whole screen, right, that's pretty good. Now we'll do the left and right. Same deal with this one. We're looking for the sharpest H, sharpest position where we can get a nice sharp H pattern, where it's defined between and it's symmetrically right. Because remember, this is setting the flare that we did on the centre, but it's just doing it on the edges. Now we do the horizontal phase, we've done vertical phase, we do horizontal now. And just get it as good as you can do, because we haven't finished with it yet. Right. Now, I'm going to push the magnetic focus button and hold it down so we can get to the rest of the menu. And push the MG focus button down. Sooner or later we should be able to get to the next one. Ah, here we go. Yep. Right, I'll just go back a bit. Just take a step back. With the plus and the minus buttons, you can forward your way through the majority of these settings. So if you think you haven't optimised one, it's pretty easy to go back and have another go. What you might notice too sometimes, if you keep and you go to the extremes of the adjustment, you'll actually see the edge of the picture fold in, and you can actually see a line that goes across the screen. No point leaving that there, so try and adjust it so that it's out. If you can't set it any sharper, just leave it so that the fold over is actually off the screen. Okay, here's where we get serious. AQP and DQP. These are three-dimensional adjustments.
So what are you adjusting there, Graham?
That's a good question. Just hang on a second. I've got to get my bearings. Okay. The issue that we've got here is we're actually adjusting up here, and because the projector's not square, it's actually projecting the bit I'm meant to be adjusting up the top of the screen there. Let's just look here, because I can actually see there. Yep. Right, so there's left and right and up and down. So we're looking to make the H pattern as sharp and crisp as we can. Do the bottom now. Remember, we're doing horizontal and vertical now. they look pretty good now. They're a lot sharper than they were before.
I'll just go in again. Sorry to keep zooming in and out, everybody, but I'll just go in on those and you see those H patterns are considerably better than they were.
We'll do the left.
So you did them using the MG after you'd already set them up, is that right?
Well, MG focus and astigmatism are two completely different things. Astigmatism is actually changing the shape of the signal. What I'm doing at the minute, I'm just going to edge focus the green tube because I think it's a bit soft on the edges. Actually, that's much better.
Sorry, what's edge focus that you're talking about there,
Well, these
Grant?
lenses have got two adjustments, haven't they? They've got the back adjustment, which does the overall focus over the entire tube face. Right, it actually affects the edges, it affects the centre. Then this one here is your edge focus. So once you've got the centre focus set, if you undo that knob and adjust this part, it's actually focusing the corners. So I find it's better to focus the edges here on the sides. So you would do them on each side and at the top and the bottom, and you'll find a spot which is a compromise. At the moment, this will only ever be a compromise because we haven't done the lens flapping, so we know that it can't be perfect because we don't know that the lenses are in the right plane yet.
Right.
By the right plane, I mean they might need to be adjusted like this so that we actually get uniform focus over the entire screen. We haven't quite got to that step yet because we're only setting the astigmatism.
Right.
So all we're really interested in at the minute is to get the H patterns as sharp as we can possibly get them. Oh, that one's pretty good. Because the absolute focus will come later when we start doing the flapping. An interesting tip that you probably should fill you in on. Over here, you know, this is fundamentally out of focus, and you think you're adjusting the astigmatism and you're thinking to yourself, oh shit, you know, I just can't get that right. Now remember, we haven't done the lens flapping yet. So if you get to a spot where it's really difficult and you can't see very well defined H patterns, the way to fix it, to find out if it is actually lens flapping, is you go over to the main focus adjustment and undo it. This is the one where you focus the centre. Right, leave the edge one where it is, but you unfocus that. Now, if you can twist those lenses and you can actually focus in the far corner and you can focus it up so that it looks good, then you know it's not an astigmatism problem. It's a flapping problem, lens flapping. What do they call it? Schemflung or whatever in the US. So it's always good if you're trying to do the astigmatism and it's too furry and you can't get it right because you haven't done your flapping yet, then just use the main focus and focus on that area that you're trying to adjust until it's perfect. Then you know it's a lens flapping problem. Once you've done that, you can actually walk over, and being able to do the astigmatism there will be 100 times better because it's now very well defined. Now we've got nicely defined H's on the right hand side of the screen. You can see there, they're pretty well defined. So we know that we've got a flapping issue, but we knew that because we haven't adjusted the lens flapping yet. So if you just focus on each part, as you're doing the astigmatism adjustments, every part when you go to the next bit and the block comes up, so there it is there, that one's the bottom corner, there's the top corner, and up there is the next one. Then just get hold of the adjustment and actually focus the corner with the lens. Then you can go over and actually do the astigmatism adjustment and everything's in focus as good as it can get, and you're actually isolating the lens Schemflung from each of the adjustments that you're doing. Oh, that's really good now. Those H's are very well defined on the edges. And any out of focus areas that you can see are more than likely to do with the lens flapping, which we'll get to soon.
Sorry about all the zooming in. I hope I'm not making everybody sick. But as Graham's going in and out, he's basically using the control panel and the lens focusing to change each area. I think you're right, I think it is 11 areas, Graham.
Yeah, I don't think it's 21.
I think it's 21 for the convergence, I think, was a 21.
Yeah. So those H's in that corner are really quite good.
I'll just come in on those again so people can see them. I'll go right in close up so you can see what my H pattern looks like.
So what we're doing is individually focusing each spot so that it's a little bit easier to tweak the sheen form. So now we're in focus up the top right hand corner, but that won't be as good down there. Doesn't matter though, because all we're doing at the moment, all we're worried about is astigmatism.
These adjustments aren't that easy to see on video, but
no, I know.
But you just
just looking for the sharpest pattern you can get. Basically.
It really is just a visual assessment. There isn't a right and a wrong. You just try and get it as well as you can. And then you do the same thing for each.
Yep, each colour. So this has taken quite a few minutes to do on the green. Of course, by the time you go around all the tubes, this is going to take up a fair bit of time. But at least doing it this way, you can actually isolate focus problems from lens flapping issues. That's actually quite good now. I'm quite pleased with that, apart from the phosphodileme spot in the middle. So what we'll do now is focus the centre again, which is actually looking pretty damn good apart from that big blob.
Yes.
And we'll lock it up.
My wonderful blob.
And we'll do the edges. And with a bit of luck, we'll find out.
The good news is though that Graham is going to set my 1292 up so well, it looks so fantastic that you'll hardly see the effects of the blob.
You're right. Okay, so that's not too bad. I mean, we've got pretty poor focus in some corners and not others. That's actually quite good there. This is not too bad there. Top right hand corner is really quite poor. Bottom is reasonable. So we've got a Schemflung issue on the lens that we'll have to adjust out later, but we should be able to fix it. Okay, well, there's no point sort of harping on with the other three colours and keeping you hanging. So we'll stop the tape now and then I'll go ahead and do the blue and the red. Okay, it's now about 35 minutes later and I've done the Electronica Stig on all of the colours. Blue was a bit of a worry, but we manually focused the Schemflung errors out of the picture and focused on each Stig point as we went around the screen, and actually came up pretty good. Remember to push the memory save button now, otherwise you'll lose all your Stig settings when you turn it off. What we're going to do now, we're going to have a bit of a go at the convergence. You all say, oh yeah, I know how to do that. There are some reasons why you have to do it the way that I say. And the majority of those is that the linearity and a lot of the other adjustments are going to be a long way out. And just remember, when we've got that green up on the screen like that, we're actually setting that up as a master, which means that we have to measure all of these squares to make sure they're the right size. We measure the vertical squares. You can see this one here has actually got a skinnier square on the bottom than what it has up the top. So that's the only way you can really set the linearity on these things, is to actually get the tape measure out and measure the squares and make sure that they're the same on both sides of the screen and the same size top to bottom. So that's what we're going to do now. We'll do it on the green because the green is our master. Get the tape measure.
Do you want a hand with this,
Oh,
Graham?
why not, Matthew? Come and put your head in the picture. Right, well we've got our block on this side of the screen is, that's 3, isn't it?
I'm standing in front of it.
315 wide. What is it over that side of the screen?
Block is 320.
Okay, so our linearity is not quite right, so we'll adjust green linearity. Turn off the blue. You only want to adjust the green, so looks like we have another choice. That's quite odd.
You have to turn off. That's it.
Let's have a look. Green raster linearity. So yours was longer. So let's shrink yours a little bit. Do you want to measure it now?
It's 325.
Oh, yours was longer. We have to make it smaller, didn't we? Other way. Measure it now. It should be about 320. What have we got?
It's about 320 there.
Okay, let's try this side. It's about 318. We'll just go across a bit more. That should just about do it.
That's about 380
Okay.
on my side.
Probably about right here too. Yep, 318. What size is this square?
Nearly
200.
Exactly.
Let's have a look here. What have we got here? This is about 202. So let's. Exactly. More. Oh, wrong side. That's it. 202 odd. 202. So I'd say our horizontal and vertical linearity on green's perfect now. Now let's just have a look at the overall geometry. Now, the interesting thing about these controls is that skew and bow really only relevant for the centre lines. Don't try and correct anything outside the centre with the skew and the bow keys, because they're just not right. That's not what you use them for. So let's just have a bit of a tweak here. It's actually got a bit of a bow in it. Good one. Try and straighten this sucker out a little bit. Keeping in mind, if we get the green right, then the others should be right. Then the others will be matched to the green, so that should be right.
So, Graham, could you do this with a laser level light?
You probably could. I tend to make my screen correct, and then work off the screen. I mean, we know the screen's right. You can see down in here, look, this corner here is actually higher than the other corner. Well, we know that it's not the projector, because we've measured that. So, really, this leads us to the point where we start measuring the relationships on the screen to try and get it right. So I suppose the assumption here is that Matthew's screen's actually correct. And I don't think that's a bad call. So we just try and get this geometry right. Measure from the corners of the screen to here. Sorry about that, we'll just use the tape measure. It's got to match the screen anyway. So to the centre line, that's 930 on that side. 925 on that side, so our skew's not quite right.
Look at this.
You're a gadget man.
Oh look, a complete gadget man. I'm just going to rest this on top of the projector, just for our esteemed audience, so they can have a quick look at what a laser level looks like across the screen.
I don't know about your laser level, but I'm happy because it measures right. Do you want to, Matthew, can you just hold this?
Yeah, sure.
We've got to measure from the centre line to the edge.
Look at that. Hang on. I think I'd stand up properly now.
I think we might give that away as a joke.
Yes. Okay.
1355. We go up to the top.
He's just jealous of my gadgets.
I've got more gadgets than you, haven't I?
Yeah, you probably know.
1355. Well, I reckon that's a pretty good approximation of being straight and level. So I'm quite happy with that. So we know that our green cross is actually horizontally right, and we know it's vertically right. But so much for the geometry on the rest of it looks bloody awful. We know the linearity is correct. So let's just have a look now and see what we can fix with the pin cushion.
Look at that. Look at my wonderful laser light. See? Look at that.
All right. Home Depot job.
Look at that. Fantastic.
Okay, we'll just fix this keystone up as good as we can. Pin cushion.
So what are you doing with the pin cushion?
Well, we've got to correct the sides. You see, if you have a look, these side bits here have got to be directly parallel with this. On
And
the
they're
screen.
not, are they?
Well, they're not. They will be in a minute, though, when I adjust them.
So you're using the pin cushion?
Using the pin cushion to straighten up that line.
Right. And what exactly does the pin cushion do to that line? Does it bring the tops back out? Or does it
I'll
push...
show you. Look, here we go. Pin cushion. So what it's doing is bowing the corners out on each side. So it's bowing the top out, it's bowing the bottom out.
Right, right.
So by pulling this in, we're basically straightening up the lines.
And what's the opposite one to the pin cushion then? If you have...
There is an opposite.
Right. So if you've
But
got...
we're going to have keystone in a minute. So
Right.
and we know what keystone correction is. It's that.
Yeah, yeah.
So what we're trying to do is to get the lines down the side of the screen perfectly level with a combination of pin cushion and keystone.
It's at the bottom, this side, it's...
Yeah, I wouldn't worry. I can sort of tell from the edge.
92.
So that's much straighter now. There will always be a trade-off between these. You will never get it perfect.
75.
So the idea is to use as little correction as possible. And if you have a look, there's actually top to bottom pin cushion as well, slightly. So we'll try and pull some of that in. You'll never get this perfect. So that's what the zone control's for.
Right.
Just measure from the bottom of here to there.
Yep.
And the same on that corner to the bottom of your frame.
Okay, we've got 135 on this side, and we've got 130 on that side.
Okay, let's use some keystone. So the keystone adjustment's actually changing that. Try another go.
Yep.
Just measure in a little bit from the corner about, yeah, that'll do. Measure that one there.
That's 130 on that side. And that's 132 on that side.
I think 2 millimetres will be okay.
Right.
Now you'll never get this perfect with just these two controls. So guess what? That's why we have zone control on green. What we're going to do now is to try and actually tweak the geometry so that we can get it perfect. So we go to zone control on green and we'll page through. We know the centre's in the correct spot. We know that's in the correct spot because we measured the linearity. We know that one's correct. We don't know that this one's correct because this has actually got a little bit of a droop right in the centre of that line. So what we can actually do now is correct that. Actually pull it in the line a little bit. And there's another one there. That's perfect. Now the centre line's perfectly straight. Now the top right hand corner, this is interesting because if you have a look, these blocks are actually not quite right. We've minimised the amount of adjustment, but they're just, the linearity is just not there. From the top to the bottom on the edges is not right. So Matthew, do you want to measure that to the top of your screen, to the bottom of that green line, the horizontal line up the top? How big's that one?
That's 160.
Okay, do you want to measure the other side?
It's 155.
Yeah, looked a bit smaller. So what we're going to do is zip through the zone control and actually pull the top one down a little bit.
Do I get to wear one of those wonderful outfits if I'm your assistant?
Oh, what sort of outfit? If it's got anything to do with leather, no.
I'm not going to be your assistant anymore now.
Okay, try that sucker.
That's 150, just 158.
Okay, try the other one.
And that's about 158.
Beautiful. So that's right. Just hit the memory thing right now and save what we've done. Now, just going back to zone control, we've got some droopy bits in each corner. 21 of these, remember, but you probably only, if this is mechanically set up correctly, you won't need to touch it in 21 positions. Actually, if I have a look at that bottom line, can you just measure that corner there to the centre, Matthew?
Corner to the centre?
No, sorry, vertically. Just from the bottom green line to the screen edge.
Yeah?
Yep.
It's about 126
And
there.
what is it at the end?
And it's 134
Yeah, it looked a bit strange.
at the end.
I might just put a little bit more pin cushion on that one. Try it now.
In the middle, it's 126.
What's that one?
130.
Okay, we'll just stay there. I'll just pull this down a bit more. What's that say?
That says 127.
Okay. That was 126, wasn't it?
And it says 127.
That's fine. So, what we've got a problem down here, we've got a droopy corner. So what we'll do with the zone control now is we'll zip through and we'll actually pull that corner up using the zone control. Try to measure that one over the side now, Matthew.
This one?
Yeah, the one in this corner here. 127 we have to be at. Right on the corner. What does that say?
127.
Beautiful. Okay. So what we'll do now, in order to get these outlines right, we'll zip through these because there are interim adjustments in the middle. I've just found the line in the middle of that one. Okay, that's looking straight. We'll go up to the top and come down to the bottom, and we'll pull this one down as well. Except it's interacting with the corner. It's all a bit of a compromise, this. So what we're trying to do is to find a good compromise. You'll never get it perfect, but you'll get it damn close. Okay, I think that looks pretty reasonable. So now what we should have is a fairly respectable flat field with no bumpy bits anywhere. We should have
Graham,
sides.
I'm sorry, on the left, it looks to me, like I'm up with Brian, it looks to me as though it's
It could very well be. If you see any spots that aren't quite right.
I'm looking at 68 there, and 89, 90 there. That's 90. Oops. Okay, that's moving out. That's 80.
Yep, that one's not right.
That's 85. And that's
Oh, it's too far out. I can see that it smiles out.
yeah, it's 75. Right.
So what we've got to do is we've got to use a combination of zone, keystone and pin cushion to get these right. Okay, that's looking pretty damn good. We've got a linearity problem, linearity issues all done. We've got our sides parallel to the screen, our bottom and top parallel to the top and bottom of the screen. And the green's looking pretty damn good. We've got a nice linear display. Now remember to push your memory save button. And also remember to push it and hold it, maybe I should point it at it, so that it copies it to all of the memory blocks. Like that. Okay. Then we'll go on and we'll do the red and the blue. There's probably not a lot of point mucking around going through all of this having you on tape, so we'll turn the tape off now and I'll go through and converge the blue and the red.
With the laser light?
Without the laser light. Okay, well I'm nearly done. The red's done, the blue's nearly done. We're just sitting here thinking of a few things that you might want to know about. If you haven't noticed, when you've got the top boards open after doing the astigmatism inside the projector, when you start converging, close the boards because the convergence changes fairly dramatically with when you open and close the actual boards on the machine. So make sure you close it before you go and spend a lot of time converging. What else was there too? Yeah, look, as I said right at the very start, the bottom line on the remote control, size, linearity, skew, bow, key, pin, each control is specifically meant to be used in the order that they're on there. Of course, you might have to go back and tweak a few things, but linearity, skew and bow, they only really apply for the two centre lines. So we're talking about the vertical centre line and the horizontal centre line. Forget about the edges while you're doing that. Get the centre crosses perfect. This is what your aim should be. Once the centre crosses are perfect, then it's the key and pin which actually you use to adjust the outside, or get it to a point where to use the zone control to correct it, you use the absolute minimum amount of correction that you know that you can. I'll just finish doing this, and then we'll talk about Schemflung. Well, now that you've finished your convergence and you've got perfectly uniform convergence all over your screen on all three colours, it's now to move on to the absolute worst part of aligning one of these, and that's doing the Schemflung. It is, without doubt, the worst job of the whole lot. PJ Calc actually does come in handy in this case because it gives you a starting point that lets you set the Schemflung rings, the flapping rings on the projector, to something that's vaguely right. It will never be right, but at least it gets you in the vague approximation of exactly where it should be. So basically get your copy of PJ Calc and feed in all of the relevant data in PJ Calc and get it to recalculate. Forget about where it says to place a projector because it's never right. Just get the information on where to set the Schemflung rings. Now,
that's it. Point to them there rings.
These little divas, these are the rings right here.
Oh, hang on, I've gone to the wrong rings.
Well, this ring, that ring, these rings.
They're the rings.
They're the rings.
Right.
Now, they're actually wedges of aluminium, so as you rotate the rings around each other like this, their actual angle relative to the front plate of the tube actually changes. Now they're like a flat disc with a hole in it, but they've got a wedge cut on the back. So as you actually turn them like this, they actually rotate in 3 dimensions. The same as the G90, except the whole way that these things work is obviously completely different. But you have to make one of these. This is my special spanner that you can't buy, and I actually had to go and buy a long reach socket. I don't know what size it is, it looks like it's about 8mm, and a long-handled screwdriver, and I actually had to weld it on because I couldn't find or buy anything that was vaguely right to do this job. After you've printed out your PJ calc thing that actually tells you what positions you're supposed to start off with the rings, these won't be right mind you, but at least they're a starting point. You use your special screwdriver and you actually undo the 4 mounted bolts like this. Actually, before we do this, I might have a look. I've actually already done the green one. I got ahead of myself. But I'll put the red one on and we can just see, and I'll show you the best trick that you can use to do this. Red. Okay, now I'll just turn the green off. Now, everybody will go, oh yes, you've got to adjust, you know, this is not right, it's out of focus down here, it's in focus here. Yeah, okay, but how on earth do you ever adjust the rings on these things so that they're actually in focus in every spot? And the answer is you can't. And the biggest single trick that I can tell you is this. Undo the actual lens focus ring and turn it, and you see that those lines that used to be little narrow focus lines, notice how they've actually stripped now. Forget about focus. What we're doing is we're trying to make the width of these strips the same in every corner. So if we look how wide this strip is here, as compared to the bottom, actually this one's pretty good, you'll see they're almost the same size. In extreme cases, what you'll find is this is actually in focus up here, and this has got an incredibly wide strip down the bottom, so you obviously can see that the lens flapping's not right. So just having a look at this, actually this lens is really good. And to be quite honest with you, I don't think we're going to benefit much by changing this one. If you look at the width of this here, it's almost the same as the width there. And it's exactly the same as the width here. So I think changing the flapping on this particular one, how it's set right at the moment, I don't think we're going to gain anything.
Well, let's just confirm for the audience. We'll just show you, we're just going to grab the camera and get a close-up of those rings so that you can see exactly what the rings look like close-up in their readings. Now you can see there, if I can...
If you look at these, the rings, if we've got the rings...
Hang on, I'll just come back a little bit. There we go, there are the rings there.
There's 2 rings, there's an inner and an outer. The forward ring is ring L, the rear ring is ring C, and if you look really close, on the front bosses of each of these you can actually see numbers cast into them. They go from about 14, plus 14 to minus 14 on each of them, and basically what they're doing is changing the relationship between each of the rings so that the lens actually moves in different planes, like this moves in different planes. Now, to actually set these, you have to undo all 4 of these bolts. They retain themselves, so you only undo them most of the way to there, and the nuts will actually stay in place. Then you grab these rings and actually change them so that the readings that you've got from PJ Calc actually line up with the numbers that are on the back of the rings there. That's your starting point. Now, if you're really, really lucky and you adjust these rings and they're correct, then you do back up all 4 bolts again with your special tool. When you come over to the screen, if you're really lucky, PJ Calc will be correct, and you'll actually see that the width of all of these lines when that screen's defocused is exactly the same over the entire screen. And I'll tell you what, this one's pretty damn good, so I'm not even going to touch those rings.
Well, what are the readings off those rings at the moment?
Well, that's a good question. Where's that torch? Oh, here it is.
Because
PJ
Calc for the red gave us L of minus 4.8 and C of 14.5.
Now C's the rearmost ring and L's the most forward ring. What actually is correct, which is what's on the screen, is a C element of 16 and the L element is sitting at -3. So as I said, it's completely different than what PJ Calc said. The irritating part about this is that how you adjust these rings is there's a real technique to this, and I'm not going to adjust the red one because I know that that's right now and it's a mongrel of a job. So what I'm going to do is turn the red one off. I'll refocus that and I'll have a look at the blue. Honestly, don't want to be doing this unless you really have to. It is very good too.
Yep, go.
The blue one's actually pretty good as well, so I won't change that. But what I want to talk about is how you adjust these if they're wrong. Now, I'll just turn this blue gun off and put the green one on. The green one's actually good now because I already fiddled with it. But the point here is, if we have a look at the crosshatch and we defocus the crosshatch, how I said before, we end up with those strips on the screen. And you can see now that this one's actually quite good. When we first started, it was narrow up here and it was wide down here, so obviously we were never going to get it right in a million years. PJ Calc gave us -9.4 and +9.4, so what I'm going to do, just to illustrate this, is I'm going to put it back to what PJ Calc said so that you can actually see the difference. Now, let's go. Seven it's set for. So let's undo these with the special spanner.
Only reason I've actually got Graham up here is because of his spanner. But I haven't told him that.
Yeah. Good thing you're at the other end of the house, boyo. If you start getting that leather wear out, you're in trouble. This is one of my least favourite jobs to do on a 1292, and it's specifically more difficult when it's upside down on a roof.
And may I say, one of the reasons why I didn't ceiling mount mine, although, of course, those people that do ceiling mount and hush box will tell you that their units not only are out of the way of all their patrons, but they're also very, very quiet. So that's...
Okay, now let's set this up. It's L is -9.4. So let's have a look. We'll move this to 9.4. And we'll move this one to +9.4, which is there. Okay, and we'll do this back up again and I'll show you exactly what will happen when you defocus. It's very easy to see where the Schemflung's got to go. Schemflung. Yeah, something like that. Lens flapping. Can't pronounce it, then I don't want to know what it is.
Yeah, but it sounds so more exotic, doesn't it?
Sounds German.
Schemflunging.
Yeah, I wonder what.
I'm
German.
going to go Schemflunging this afternoon.
Sounds like some sort of weird ass skiing, really.
Would you like to come Schemflunging with me?
Are you a girl if you say that? Okay, let's have a look. Turn the camera around. Now this is the PJ Calc settings. This is what I'm talking about, the width. If you have a look up there, see how wide this is? And see how narrow it is down here. Obviously the flapping, the focus is never going to be right. Because if you have a look, it doesn't matter if you focus the middle, this is always going to be under focused and this one's always going to be over focused, so you're never going to get it right. So the whole idea of this, we've got the starting point with PJ Calc, but how you actually move these rings is pretty important. If you think about it, you've got two wedge-shaped discs that are sitting there like this behind the lens. Depending on where the wedges are, and keeping in mind this is the green tube, so in theory the side to side should be correct. When you rotate those discs, what you're doing is you're actually moving the lens plane like this so that it focuses in the correct spot. So if you think about what we've got here, we've got one set for minus 9.4 and one set for 9.4, positive 9.4. Well, what we want to do, because we've got an irregularity top to bottom, we actually want to move the lens like this, which means that we've got to actually rotate the rings opposed to each other so that the wedges actually start to impose their way down on the lens and push the lens forward like this, so that the bottom will be in focus. So what we're doing on the green lens is we're actually going to the two rings are like this, the lines mark up there, we're going to actually move them in opposition to each other until this either gets better or gets worse. That'll depend on which direction we move them. So if we move them one or two places, either this is going to get wider than what it is now and this is going to get narrower, or this is going to get wider and that's going to get narrower, which is what we want, because we want this to be the same width the whole way across the screen. So if I undo those bolts now and put it back to where we know the correct setting is, which is plus and minus 7, what we're doing is changing the lens plane to the tube and reducing the amount of chamflin. The green tube is actually really easy to set, because you know that if PJ Calc gives you symmetrical figures and you've got your setup of the projector perfectly square to the screen, as we've said before, then we know that we haven't got an error from this side of the lens to that side of the lens. The only error that we can have is like this axis like that. We can't have that error because we've actually measured these to the screen, so it is correct. So if we have the same numbers on the top here, what we're actually doing is changing this only. And that's why we're pushing these rings in opposition to each other, because the wedges are actually just changing the forward and back focal plane of the lens like this. So let's put this back to minus 7 plus 7. Tighten these back up. Now that's the easy part. It might take you 4 or 5 goes to get this right, but you have to remember which direction you're turning the rings, because if it gets worse by moving one to the back one to the left and the front one to the right, then you know you're going in the wrong direction. So you've got to go back in the opposite direction of the rings that you've done this time, and you keep moving them in opposition to each other until you know it's correct. But this only ever works if you've done the preparation and measured the actual projector distance from the screen and got it perfect to the millimetre. That's why the setup of the actual physical placing of the projector is so important, because if that's wrong, this is really hard to set. Because instead of having turning the rings in an opposed fashion, you'd then have to turn both of them in one fashion either way to try and get the side focus correct, which unfortunately is how we have to do the side ones. Because they're not in the centre of the projector, these ones here have got to be altered in 2 axes. They've actually got to be altered up and down like this, but we've also got to do that, because if you have a look at poor lens flapping, you'll actually see that it might be this corner up here might be in focus, that corner down there might be out of focus, but you also might have an out of focus portion compared to the top to the bottom, so you're actually working in 3 axes, or 2 axes, sorry. So what we're doing now, we not only have to take into account whether the lens is pointing down or whether it's pointing up, but also whether it's pointing left and whether it's pointing right. Now, the issue here with whether you've got a left or right bias on the lens, whereas with the green one we're actually only adjusting it forward and back, this one we've actually got to adjust it from side to side. So we set it with PJ Kelp, and then we move the pair of rings together to the left or to the right. And what that'll do, it'll actually focus these corners up. So if you move them together, you'll end up with, in the correct direction, you'll end up with the same thickness lines in that corner as what you do in that corner. So when you've got that correct, and there's still got a thick line down here and a thin one up there, then you know that once you've got these corners set right, then you have to move the rings in opposition to each other, because that inclines it for up and down, and that'll be the fix for this one. So it's very involved and you have to get your head around it. It is absolutely useless trying to do this unless you defocus it and just look at line widths. If you try to do it and make the lines focus, you will never get to the point where you can actually see what's wrong. The really cool part about this is if you've done the red and the blue, once you've done the red one, read the numbers off here, oppose them. So if the C is at minus 14 and the front one's at some other figure, then the back one on this one is the exact opposite of that. So let's, for argument's sake, say this red one, the L ring, which is the front one, is at minus 4.8 and the back one is at 14.5. You know that the blue one is then at plus 4.8 and minus 14.5, because it's in exactly the same position but on the other side of the machine.
As long as the machine
is square to the screen. If the machine is not square to the screen, this will never work, and it'll take you 100 years to try and get this under some vague control. So that's where we are with lens flapping, and we've actually got a really nice uniform focus across the entire screen, apart from his detached green blobby thing that's in the middle.
Oh yeah, thanks.
Yeah, no problem. It's actually really, really good and very uniform across the entire screen from left to right. Right, well, it's been a bit of a long day. It's now 8 o'clock at night. We started working on this at, what time was it? About
10 o'clock this morning?
10 o'clock this morning. Our flapping's right, our convergence is spot on. We've actually aligned a couple of different memory blocks, one for NTSC. We've been mucking around with a scaler. We've got 1080p going onto the screen, and I've got to tell you, it looks spectacular. And the last thing that we did before we drew this to a close was disabled the AKB. You probably read about the issues on the black level bounce at high scan rates. Problem was, when you go from a light to a dark scene, you can actually see the black level bouncing as you go from one scene to the next. Well, you can disable the AKB. The AKB is a way of equalising the beam currents between the tubes, and in practice what this means is that when you first turn it on, it actually looks at the beam currents for the 3 tubes and then automatically equalises them so they're the same. So over the life of the tubes, as the tubes age, it actually varies the current and the amount of current that's going into them as the tubes age, and evens them out so that the colour balance doesn't change. Problem is that it has some really ordinary side effects, and one of those is its black level restoration. The machine's black level restoration can be fairly poor because the black level's constantly changing depending on how much beam current the tubes are pulling. Well, you can fix this On the top here, there is normally, on this little connector right here, there's a little wire link, a white plug with a red wire link. If you pull that wire link off and go to the back of the machine...
Well, this is going to be interesting.
What, you're round the front and I'm round the back?
Hang on, we're just going to move the camera.
Okay. Now we've got a good view. Then you reattach the link. There's the link there. You reattach it onto the connector on this small board underneath the top flap. What this does is it disables the AKB completely so that the machine no longer automatically compensates for changes in beam current. And you think, oh geez, it's meant to be doing that. Problem is that these machines weren't originally made for home theatre. They were made to be showing data displays in boardrooms and all sorts of other things. So they didn't give a rat's ass about black levels and beam currents. All they wanted was to display their PowerPoint presentations on the wall. Well, you can fix it. There are a couple of problems with actually disabling the AKB. One of them is that the gain and the colour balance will now be completely different than what it's meant to be. Just to give you a bit of an idea, because we're talking black levels, originally the red was at 168, the green was at 134 and the B was at 52. They were the gain settings before. After the AKB was disabled, the beam settings are now red 234, green 248 and blue 243. So you see we've had to raise the black levels up significantly and to compensate for the fact that we've now got the AKB disabled. But I tell you what, after sitting down for half an hour after we've done it and having a subjective look at the picture, it's awesome. There's more detail in the blacks. There is more absolute black in the pictures than what there ever was before, and it basically made the picture enormously more dynamic than what it was. So I think we could only, after what, half an hour, Matthew?
Oh yeah.
Totally recommend. Link out the AKB and redo the white balance.
And look, if you have to take the hit later on and you have to readjust it, I think it's worth it.
It should be good without with the AKB disabled. I'd be greatly surprised if you had to have a look at the white balance any more than every 800 to 1,000 hours. I mean, in my case, that'd take me about 2 years to put that on. But what I can tell you is, it looks absolutely stunning.
We'll
just
give you
put something on.
We'll give you a quick screen grab of something now, so that you can just see what it looks like. We're not sure how well it's going to come across on the video, but we'll try it anyway.
This is super bit vertical limit.
This is just off a Oppo Digital 917 DVD player, scaled to 1080p through an old Vision Lumigan processor at 1080. So again, I'm not sure if you can see the detail there, but
trust me, it looks stunning. But one of the better 1292 pictures I've seen.
But the detail level is excellent. And also the black levels, we've managed to get quite excellent black levels. Again, of course, it's just not coming across on video at all, but of course it very rarely does.
So that's the end of the 1292 alignment instructional video. I mean, I've been promising to do something like this for probably 2 years, and I keep constantly getting asked by people at ABS when on earth I'm going to do it. Well, now you've got it.
Hello. We just thought we'd show you what it looked like when it was all put back together. That's 1292. I've got it in a sort of semi-hush box on the table in front of the screen. You can see it fits between some chairs and whatnot. Now, this has got the fan modification installed. That means all the fans have been changed in my 1292. You can find the changes on AVS forum, and they're under something like just how loud is the 1292. It's a great article. It follows a whole series of posts, and at the end of the whole catastrophe, somewhere at the back, it actually describes exactly which cooling fans you replace with which ones in the 1292. Now, proof of the pudding, of course, is in the eating, and I'll just show you what my meter reads at about a metre from the unit. In other words, where I sit I get about 45 on that, and as you can hear in the background, it's fairly quiet. And that's what it looks like. That's just the page onto the screen.
If you've got any additions or anything like that, feel free to pass them on via AVS. Now what we're going to do is enclose on the disc. We're going to enclose about 4 or 5 different
test pattern
generators that you can use on your PC. We're also going to include a full copy of the Sony 1292 service manual, and of course the video.
And PJ Calc.
Okay. Okay, thanks very much. Hope you managed to sit through this epistle when you and you've been following us step by step.
It's not too boring for everybody. Thanks, guys.
Bye.
Bye.